Hello and welcome to the second video. This video is going to be concerning another distribution. It's called T-distribution. In order to have a T-distribution, we need to have two things. The standard deviation for the population is unknown and the number of the sample size is less than 30. So let's take a look at this. I'm sure uh, we will have to verify if the sample size is less than 30 and we don't have the standard deviation for the population. Let's read it slowly. The average IQ of the adult population is 100. So the null hypothesis is going to be based on the fact that age 0 mu is going to be equal to 100. A researcher believed that the average IQ of the adult is lower. It's not higher and it's not equal to lower. A random sample of 5. Well, that's already indicate there is a problem with the normal distribution, but we still have to make sure that we don't have the normal, what do you call it, the population standard deviation in order to get the normal distribution. So 5 so far is less than 30, and they're not giving us anything about the standard deviation for the population. They give us the standard deviation for the sample, which is 15.87. So it's those values are giving 69, 79, 89, 99, 1 over 9. And we wanted to see if we can reject or return the null hypothesis. If there is enough evidence to suggest the average IQ is lower, we will say there is evidence. There is enough evidence to suggest the average IQ is lower if we reject the null hypothesis. If we don't reject the null hypothesis, we don't have to change anything. We just leave it as it is, 100. So let's go ahead and walk you through this step because we're going to be doing it both calculating and also we could look it up in the book or we could actually use the Minitab. I would like you to use the Minitab in order to determine the critical value for T. It's much easier, much faster. Also to remind you of those 5 steps that we're going to state the null hypothesis and the alternative hypothesis. We're going to choose the level of significant alpha. If it's not known, we'll settle down for the 95 confidence interval, resulting into alpha of 5%. I'm 0.05, and we're going to find the critical value, and that is going to be, we're going to be using again either the books in the back of the book, or we're going to use Google if you wish. There's plenty of calculators that will calculate the critical value for T or Z. And also we're going to find the test the statistics. We're going to be using the formula for the T-distribution, and eventually we're going to draw our conclusion. Let's go ahead and go through those steps. I'm going to be moving to Microsoft Word one step at a time. And as you see here, I'm stating the null and the alternative hypothesis. Mu is going to be equal to 100, as we stated from, they stated in the problem that mu is less than 100 as the alternative hypothesis. Since we don't know really we don't have a clear idea about the alpha, so we're going to assume it's 95 confidence interval. I'm sorry, confidence level, resulting into A is going, alpha, not A, but that's a Greek letter, not an American letter. Alpha is going to be 0.05. So I wanted to see what is the critical value for T. I was playing with it already, but I wanted to make sure that I could get it directly from the software Minitab that is accessible to all of you. One thing we need to make sure that there is something called the degree of freedom, and we're going to face this exact story with the chi-square. The degree of freedom is the number of the item minus 1. In the chi-square, maybe we could say the number of the outputs minus 1. In this case, I have 5 values. If you recall from the value, we have 69, 79, 89, 99, 109, 5. So the degree of the freedom is going to be 4. So let's keep that on the side so we don't forget that the degree of the freedom is 5 minus 1 is going to result into 4. Now, I'm going to go and see how we're going to apply that in Minitab. And I'm going to, first of all, let me delete this and start a graph. And I'm going to go to the probability distribution. And we're going to choose the view of the probability, okay. However, we're going to change the default one, which is normal, to T. And now it's asking us for the degree of the freedom. Of course, here we're going to put 4, and we're going to go to the shaded area. Remember, we decided to be less than, so it's the left side at the probability of 0.05. It's one tail, 0.05. If it's two tail, we'll have to move to here. So we're going to go ahead and click OK. Then we're going to get the critical value for the t based on this. And here it is. It's minus 2.132, which makes sense since it's going to be to the left side. It's going to be a negative value. It's going to be a negative value. So I'm going to go to my Microsoft Word, which I'm using as an editor here. We're going to say here minus 2.132. Now we're going to go ahead and go to calculate the actual t-test. We're going to use the formula t is x bar, okay, minus that's the sample mean minus the mu, and that is going to be divided by the s. Now it's a standard deviation for the sample divided by the square root of the n, which is 5. So I'm going to go ahead and use Excel for that purpose. It's much easier to do it this way. And we're going to go ahead and say t is going to be, I'll do it usually in 2 steps. So we're going to go ahead and say basically, in this case, I want it to be able to run the t. T is going to be 105. I could do it manually by adding all these values, or I could go ahead and directly use Minitab because this is not really a summarized data, but we could go ahead and really go ahead and look it into Minitab instead of doing it manually. So let's go back to Minitab, and I'm going to go ahead and see here I did actually enter the data. I'm going to cut this data and put it into put it into cell 1, and I'm going to paste it. So since this is a little bit more we could do it manually very easily. You could find the mean, and I could actually show it to you where you could find the mean, and then we could subtract that from the 100 divided by its 15 point whatever, it's divided by 5, and we could come up with it. But let's do this time using that software itself. So we're going to go ahead and use the software itself for this t. So those are the 5 values. And I'm going to go to the stat, and I'm going to go ahead in basic statistics. I'm going to go to one sample t, and notice here we do have not summarized data. We do have one or more sample, which is going to be actually in the C1, which is IQ. I'm clicking on it. Let me go ahead and delete this. Sometimes you can click on that. It moves, and the hypothesized mean is 100. We're going to check the perform hypothesis test, and we go to the option, make sure that's 95%, and the mean is less than, and we're going to click on this, and hopefully we'll be able to see that actually that t value is going to be, as a result of that, with all the data that we chose here, 69, 79, 89, 99. Oh, that's why I got a different value than what I expected it. This one's supposed to be 109. 109. So I'm going to rerun it again. It's good to make the mistake, so we could go ahead and do it again. So I'm going to leave the mistake, and we're going to go to the statistics, T1 sample T, and still the same data. You see here, data. I could delete this and refresh the data. There we go. Click on it twice. Still, it's the hypothesis test 100. It's going to be the option here, and I'm going to leave it at 95. It's the less one, and you will see that we're going to have basically minus 1.58 or 6 basically. And this is, if you take a look at it here, if you remember when we did the graph for the probability here for the t's for 4, and it's only single at 5, you notice it's going to be minus 2.13. So the minus 1.56 is going to be really here. It's going to be real here, which is resulting into a falling into the acceptable or failed to rejection reason. So we cannot conclude that this is actually, we cannot conclude there is an evidence as it was stated. We could take a look at the problem again. We cannot conclude that there is evidence to suggest that the average IQ is lower. So we're going to stick with the fact that the IQ is of the population is 100. But I'm going to take my time here and play a little bit with it to show you that yeah, if we run the test, as you notice here also, I'm going to delete this. Look at p-value, which is 0.097. It's not less than 0.05. Therefore, also we have a clear evidence that we cannot reject the null hypothesis. We have to retain it. We have to accept it as it is. But let's go ahead and play with the data, just to play with it. I'm going to go get very small data, very small, not, instead of saying like 69, I'm going to do 37. And I'm going to do 34, then 74, then 23. I'm really exaggerating with this in order to get the point across. If I run the test, remember my critical region start as minus 0.2132. So we have to get a value less than minus 2.13 in order to rejection the reason. With this very low type of IQs, we will be actually getting some values. I'm assuming, but I don't know until I run the test. So I'm going to go to the graphs again. The test stat. Go to the basic statistics. Go to the sample T, and again I'm going to delete this just in case. Click on this to refresh the data and leave it as the hypothesis test. The mean is 100. The option is still less than 95. I'm saying here it's less than the alpha of 95, and I'm going to say here less than the 100. I'm going to go ahead and say OK. And notice now, wow, we got minus 6.15, and therefore it's clearly that this is going to be way far to the left of the minus 2.12 because those scores are very low. Therefore, we can now reject the null hypothesis, and we can state there is a clear evidence to suggest the average IQ is lower due to the fact these type of data that we chose were indeed very low. Okay, again, if I could go ahead and do one more thing very quickly, if I did this data to be like 150, that's kind of genius level, or 130, I put it, 50 is, and 151, I put 110, 115. There's no way we could reject the null hypothesis because those are going to be very high IQ. And you will notice that the p-value, as we did in the rejection, way too small, 0.002, which is much smaller than the 0.5. Notice now, because those IQ are so higher and I'm testing at lower, it's not going to really be rejected. So I'm going to run it and show you. The statistic is becoming so, the more you use it, the more you're related to it, just like in social science, So I'm going to go ahead and say, all right, this is basically what I'm going to delete here. And click on this again, and I'm going to keep that the 100, and I'm going to keep the 95, and I'm claiming still it's low. Wait, it's crazy because those are actually 150, 151, 110, 115, 130, and I'm saying this is going to be lower than the 100. And if I run the test, wow, it's 3.78. That's impossibly close to that minus 2.132. So it's way, and look at how large the p-value is, almost 1, to say you're way too crazy to even attempt to reject the null hypothesis with this type of data. You're claiming that these people have a lower IQ than 100. Look at your data. One of them is 150, 151, 110, 115, 150. I hope you learned something through this, and I would like you to practice this. If you practice, you have no problem whatsoever on the test. Thank you.